Hi everyone, it's Alex, and this is my rundown of day 2 of Advent of Code in 4th, Cube Conundrum. So in this problem, we're given a list of games that are described through these strings, and what we're meant to do is see if the game is valid or possible in the language of the problem. And the way that we do that is we see if the number of green, blue, or red cubes exceeds the maximum number of 12, 13, and 14. In part 2, we're asked instead to look at the games and see the minimum number of each cube that has to be in the bag in order for the game to be possible. So the way that I went about solving this is a common approach to solving problems in Fourth, especially the Advent of Code type problems, which is you define words such that the input to the problem is a Fourth program. And so you can see on line 19, what I do is once I've set up my words appropriately, I read the input file as a Fourth program, and then I get the answer. And so this is the data as code principle. So the reason that I can do that is you notice that certain aspects of the program look kind of like a Fourth program. So for example, 3, you put 3 onto the stack. Blue is a word that has some sort of operation that consumes the 3 that's on a stack. So when I saw that, I was like, that's how I'm going to approach the problem. There's a slight complexity in that these words are not exactly, there's these semicolons, there's these commas. If they were just space separated, this would be very straightforward. But essentially what I have to do is I have to cover all of those cases and just alias the words, essentially. The approach then becomes defining red, green, and blue. And so for part 1, we have the 12, 13, and 14 over check. And then for part 2, we basically have a running max of the max number of cubes of that color. And then we then define game such that it parses or updates the values based on that game. We define checkline so that if it's not bad or impossible, then we add the game number to the total. And then we, for part 2, we multiply RGB values together, and then we add that to the total. And then because the input doesn't have like a game here at the end, what we have to do is we just call checkline once after the last line, and then we print the output. And so if we run the problem, we can see part 1 solution here, 2331, and part 2, 71585. So one thing that was a little bit interesting is you have to define this skip function. And so when game is called, we basically just ignore these characters. And so we just advance the input until we see a space. And so that's how we skip that. So I thought this is kind of an interesting solution where, and a lot of things, a lot of Advent of Code input looks a lot like a Fourth program. And so you can be kind of creative, redefine the interpreter such that the input itself solves the problem. If you thought this was interesting, you can see the code in the description, and I encourage you to subscribe for more Fourth Advent of Code updates.